A population of dogs is in Hardy-Weinberg equilibrium. The allele for white fur, capital W, has an allele frequency of 0.20, and the allele for black fur, lowercase w, has an allele frequency of 0.80. Find the percentage of heterozygous individuals in the population. I'm just going to first start off with writing what equations I know are associated with Hardy-Weinberg equilibrium. And as they were on that first Hardy equilibrium slide, I believe, with the equations, it would just be these ones. So it's telling us the allele frequency. So we know capital W is going to be equal 0.20. And we know lowercase w is going to be equal to 0.80. Capital W is going to refer to our dominant allele, and it's the allele frequency. So this means our P. This is going to be our P value. And then, since this is lowercase, it's going to refer to our homozygous recessive allele frequency, which will just be Q. So there's two ways you can approach this problem. I'm first going to do a more complex method, and then I will do a much simpler second way of doing it. So for the first one, since we know these values, we know the P and Q, let's write out what we know. So we know P is going to be 0.20 plus 0.8, remember P, Q, and that will be equal to 1. And while this doesn't tell us this heterozygote value, this is just this first equation, the only difference between this one and this one is that this P and this P is that this P is squared. So we can actually just square our values, kind of make a little box here. And still the 1 is always maintained. So if you have a difficulty kind of looking at this and knowing what 0.20 squared is, you could just always draw a wonderful little multiplication thingy over here. 2 times 2 is 4. 2 times 0 is 0. Always drop a 1 because you're onto the second place right here. 0 times 2 is 0. 0 times 0 is 0. Add them together. Got two values on this right side of the decimal place, so we're going to go 1 over, or 2 over like that. 1, 2. 1, 2. 1, 2. Giving us 0.04. And then this one, in my opinion, is much easier to do. 8 squared normally is always 64. So I'm actually just going to write 64. It's a decimal. Just like that. And then this should be equal to 1. And again, if this confuses you, this step, always just go on the side and write it out for sure, just to know for sure that you're right. But these two together, I know is going to be this number, 0.68 equal to 1. So at this point, we've made it. These are our P squared, Q squared. And we know, since we know what this value is, and we know that it's always equal to 1, we can kind of just denote the heterozygous value is X. And this would actually be plus. So whatever the heterozygous value is, plus what we know, 0.683, the frequencies of these two alleles, it should equal 1. So we're just going to subtract here. In this, draw it out or do the math if you need to on the paper, but I just know that this is 0.32. And then we could just automatically convert this to a percent as such. That was the much more drawn out, maybe not so complicated way, but a much longer way of doing it. There is a much shorter way of doing it, so we can just start off what we kind of originally started off with, P plus Q equals 1. Right? If we know P, again, 0.2. We know Q, 0.8. This equation, or this rather value up here, is just 2PQ. So you could actually just do this. And you really don't even have to worry about the decimal here. So if I'm looking at this first, 8 times 2 is 16, right? Solve the parentheses first. 2 times 16 is 32. And like I said, it's kind of just automatically goes into a percent anyway, so you can just kind of make that the percent. And oops, sorry, I didn't know that this was being blocked. But just to go over it then really quick, we know these values, right, because they were given to us. This is simply 2pq from the first equation right here. So 2pq, 2 of 0.2. Plug it in really, 2 times, and then 8 times 2 is 16, 16 times 2 is 32. Solve the parentheses first. Please excuse my dear Aunt Sally, and then 2 times 16 is 32. And don't even, like I said, you don't really have to worry about the decimal places because you kind of know that whatever this value is, it's going to be translated into a percent.